lesson, we're going to talk about something called the slope. So we're actually going to see if we can find the slope on a graph. Now, first of all, before we worry about finding the slope, it probably would help if we knew what slope meant. And if I ask most students, well, what do you think of when you hear the word slope, or where do you deal with that word the most often? Almost every student in class will say, when we think of slope, we think about our ski hills out at Alpine. How steep is that slope? And that's exactly what we're looking at is when you look at the slope, is it a steep slope or is it kind of a flatter slope? For example, the Bunny Hills have a pretty flat slope. You know, Bunny Hills aren't too steep. Where if you go on one of the bigger hills, now they're a lot steeper. So when we talk about slope, we're talking about how steep or how slanted a line is. Now, what line? The lines that we would be graphing, and then we'll get into those a little later in the year when we talk about graphing linear equations. But for today, we're just worried about how we find the slope of that line, how we determine or label how steep it is. To do that, the first thing we want to look at is something called the rise over the run. Now that's the mathematical terminology, rise over run. When you get into algebra, pre-algebra next year, they're going to use that term, rise and run. Not that I don't like those terms, but a lot of times students get confused. Rise and run, I like the words up and over because all students know what I mean if I said to go up, and if they mean to go over, they jump and go, oh, that means left or right. So I like those terms better than rise or run, but again, the mathematical terms are referred to as rise over run. So what does that mean? It means that when we look at any 2 points, if we find any 2 points on the line, we simply want to know how far does it take to go up from one and over to get from one point to the next. Now, again, rising means to count up, run means to count over. And again, that's why I use that up and that over, because to me that's just an easier way of doing it. There's also a couple other things that we have to worry about is our direction of our line. Whether it slants up to the right or slants up to the left. And if you think about it, if we go up to the right, right are where our positive numbers are. And if we would go up and to the left, that's where our negative numbers are. So anytime you have a line that slants in this upper right direction, it's going to be considered a positive slant as opposed to a line that goes up to the left. So remember, if we find any 2 points, we're just kind of looking at one and say, how far would I have to count up and over to get to the other point? For example, if I looked here at this example, they use these 2 points right here and here. And if I go from this point here up to this point here, I simply count up how many squares. 1, 2, 3, then over 1, 2, 3, 4, 5, 6, 7, 8 squares over. So the slope for this would be, this is how many I went up, this is how many I went over, or my rise over the run. Okay. So this line would have a slope of a positive 3/8 because it's slanted to the right. We're just going to go through a couple of these. Again, the easiest thing is to take your pencil and put it on one point and count up. 1, 2, 3 lines. Count over. 1, 3 over 1. Now, if we have an improper fraction, we don't necessarily want to change it to a mixed. So if I had 5 halves, I would leave that as just 5 halves. However, if we have a fraction that can be divided, 3 divided by 1, and gives you a whole number, then you want to convert that to just a whole number. So again, if I had something like 6 over 3, you could divide that and say it's 2. If I had 9 over 4, we could just leave it and say it's got a slope of 9/4. Okay. So you don't have to do that. However, if you do have a fraction like 3/9, you would want to reduce that and say that its ratio or its slope is a 1/3. Okay. All right, all I'd like to do is I'm going to show you one, have you mentally kind of go through it, see if you can get the answer, and then I'll give you the answer. We'll do a couple, and then there's a few other things I'll need to show you as we progress. So see if you can find, and notice I have 2 points on the line already marked. Start at the bottom point, count up. That's your rise, your top number. Then you count over. There's your bottom number. Rise over run, or up and over. Okay, so hopefully mentally you went, okay, I went up 1, 2, 3, 4 spots up. 1, 2 over, 4 over 2, which does divide evenly. This has a slope of a positive 2. Positive 2. All right, why don't you try that problem mentally? See if you can get that slope. Okay, if we look here, we went up 1, 2, and I go over 1, 2, 3, 4, 5, 6. So it's a slope of 2, 6, which we could reduce to a slope of 1/3. And because it's in this direction, it is a negative slope, a negative 1/3. Let's try one more, and then there's a couple things I'm going to show you. Let's try one more. See if you can find the rise over run, or the slope of this line. And if you look at it, it's a pretty steep slope. So my guess is it's going to be a big, it's not going to be a fraction. It's going to probably be a improper. So we start here. We go up 1, 2, 3, 4, 5, 6, up 7, and over 1, 2, 3, up 7/3. It's in a positive direction, so it has a slope of 7/3. Pretty steep. Pretty steep. When you start getting over slopes of 1 and 2, it's pretty steep. All right, we're going to skip a couple more of these, and I want to go to what you're going to see for a couple problems on the assignment. There's a couple problems where they're just going to ask you to find the slope of the line created by the following points. Now, remember, these points, first of all, are kind of backwards. I mean, up and down. Usually we see these points written like such. So that's 0.24. This is 4, -1. You just got to see the x and y coordinate for each point, and then 6, -6. Oops. Sorry about that. 6, -6. Now you only have to graph 2 of these points, and it doesn't matter which 2. So we'll graph one of the points first, to 4, over to 2, up to 4, and then we'll graph the second one next, 4, -1. And now we look for the slope between those 2 points. Up 1, 2, 3, 4, up 5, over 1, which would give us a slope of 5. And it is going in a positive direction, so we leave it as a positive 5. Again, when you look at something like this, and just to prove that it can use any 2, I'm going to graph all 3 of these points. So first point is at -3, -3. 1, 2, 3, 1, 2, 3. It's kind of hard for me to see my lines from back there, so is that 3 and up? I think that's only down 2. Next point is at 2, 2, over 2, up 2, and the last point is at 0. Now the one thing that you'll notice is if you graph the points correctly, these points will all line up to form a straight line. And that's one of the reasons why we call these linear equations. Now, when you do this, you can say, well, how do I know which 2 to use? I'm going to use all of them once. So let's say I was going from this point to this point. Up 1, 2, 3, over 1, 2, 3. So that's 3 over 3, which would have been a slope of 1. Okay. Let's say I was using these 2 points. Up 1, 2, over 1, 2. Oh, that's a slope of 2 over 2, which also equals 1. And let's say I decided to use this point and this point way up here. Up 1, 2, 3, 4, 5, over 1, 2, 3, 4, 5. So I get 5, 5. Notice, at all of these slopes, we ended up with a slope of 1. So it didn't matter which 2 I picked. We always get the same slope. Okay. One last thing I need to point out, because you're going to get a problem that looks similar to this on the assignment too. And first thing is you got to find 2 points. So you find a point there and you want to find 2 spots where they connect and they cross in nice even spots. Now here's what some students would do incorrect. Oh, it goes up 1, 2, 3, 4. It goes up 5. Goes over 1, 2, 3, 4, 5, 6, and say it's 5, 6. Sorry about that. The problem here is each one of these intervals are not even intervals of 1. So you've really got to look at the intervals on the side of the graph, and on the bottom axes to determine how much we go up. So for example, if I'm going from here to here, that's really from 10 to 20. So there's 10, 20, 30, 40. I'm going up 50. I'm going over. Now my interval is going 4. I go over 4, 8, 12, 16, 20, 24. So instead of the 5, 6 slope, it's really a 50 over 24 slope. Now when we see that, this can be reduced to 25 over 12. It's got a slope of 25 twelfths. So again, slope is referring to how steep that line is. And you really got to be careful, look at axes. On a coordinate graph, every spot is just 1 over. But on something like this, you want to watch your axes very carefully. Okay. Assignment for today is on page 168, numbers 3 through 17. You'll need a piece of graph paper for 4 of the problems so you can graph the points and then find the slope between them. So if you need a piece of graph paper, you should be able to find one on my webpage.